Hello, boys and girls. This is your science lesson from yesterday, October 13th. Be sure you are ready to learn. You're listening carefully, you're entering prepared, you're arriving on time, you're respecting everyone, and you never give up. Today, we are going to learn about motion so that you can demonstrate and observe how motion can be changed by pushing and pulling objects. You know that you have gotten it if you can describe how position and motion can be changed by pushing and pulling objects. So what is motion? When we say that something is in motion, we usually mean that it is moving, but motion has a special meaning in science. In science, motion is a change position compared to a place or an object that is not moving. Here are some examples of motion, which we see every day. Acceleration is the increase in the rate or speed of something. Deceleration is the reduction in speed or rate. Acceleration is like whenever you're going somewhere and you pull out onto the road and you start going really fast. Deceleration is whenever you're coming up to a stop sign or a car pulls out in front of you. You're coming up to a stoplight and you need to slow down. That is deceleration. Can you think of any more examples of motion? I want you to think about it and write down some examples of something accelerating and write examples of something decelerating. Newton's first law of motion. Newton's first law says that an object is in motion, it tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an outside force. Inertia is when the movement of an object stays the same. So let's look at these two pictures. How do these pictures show Newton's first law of motion? I want you to think about that. You have one that is moving and you have one that is at rest. Newton's first law of motion says that an object in motion tends to stay in motion and that an object at rest tends to stay at rest. So Newton's first law of motion, inertia, which is an object will not change its motion unless acted upon by an unbalanced force. If it is rest, it will stay at rest. If it is in motion, it will remain at that same velocity. Objects with greater mass have more inertia and it takes more force to change their motion. So let's like this. Something that's heavier, it requires more force to get it to move. Something that is smaller doesn't require as much. Newton's second law of motion. So let's look at the picture of the people pushing the truck. It's going to be much harder to push this truck than it is to push the car because the truck has less mass and less acceleration than the car does. So it's going to take a lot more to push it. It's going to be easier to push the car because it's not as heavy. So think about how these pictures show Newton's second law of motion. Newton's second law of motion, if you apply more force to an object, it accelerates at a higher rate. So we have force, look at this top one. And there's mass in there, there's something in there, and acceleration, the speed increases. The more force you put, the faster the acceleration is, the faster it goes. To get the wagon to accelerate, you have to apply a pull force. If the mass of the wagon increases, a greater pull is necessary to accelerate it. So you're going to have to really put forth a lot of effort to get it to go. Okay. So think about how these pictures show Newton's third law of motion. Newton's third law of motion says that for every action, there's an equal and opposite reaction. Forces are always found in pairs. If the forces are equal in opposite directions, the force will not move. The forces cancel each other out so that the acceleration is zero. If one force acting in one direction is greater than the force acting in the opposite direction, the object will move. So look at these two pictures. How is Newton's third law of motion applied to these pictures? Newton's third law of motion, if the force is acting in one direction is greater than the force acting in the opposite, the object will move. Okay, so look at these pictures. Think about a balloon and when you let it go, what it does. So we're not going to do a breakout room since this is a recording. Newton's first law of motion, an object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion will continue with constant speed and direction unless acted on by unbalanced force. Newton's second law of motion, the acceleration of an object depends on the mass of the object and the amount of force applied. Newton's third law of motion, for every action force, there is a reaction force equal in strength and opposite direction. Okay, that is the